Welcome back, everyone. In this session, we will continue to demonstrate the single element data retrieval. We already discussed the theory, so let's go to the practical part of it. And let's see how these single element data retrieval APIs can be implemented. You from the previous sessions, you already know how to open the case. I have already opened save nw.sav case, which is already available in the example. When you perform the installation, you get this case. So I've already opened this case. So let's start with the solve. Once you get this case is already solved. So if I want to check what is the status of my case, what I can do is I can simply write PSSPY dot solved, and it is going to return an argument to me. If you remember from the previous session, what we said that this ival value, it has different values. So 0 meant met convergence tolerance. So this means that my case has properly been solved. So this way you can check your case, whether it is solved or the iteration limit has exceeded or your case has blown up. All these things you can see from here. Similarly, let's try the mismatch. Let's try to see what is the largest mismatch in this particular case. So I can write PSSPY dot sys MSM, and so this is the largest mismatch, and this is in MVA. So if you want to see more details of it, you can go to the API file, the PDF file, API document, and from there you can see what are the different details and what kind of output this particular API gives. So moving on, let's see what is the base MVA of this particular case. So PSSPY dot sys MVA. So the base MVA is for this case is 100 MVA. Moving on, let's try another one. We discussed systot, which tells the total. So let's try this one. PSSPY dot sys dot. But for systot, we need to provide the argument. So there were several arguments which we could provide. So let's start with load. Let's see how much load, demand or total load which has been modeled in this particular case. So here you see, this is very important to understand what you are getting here. You are getting three kind of information in this particular output. So the one with the 0 here, this means the error part. So if you would see this API, you will see the command, Python command in this form. There will be one error value, then there is going to be a complex value which will be equal to systot and this. So this is the error. Error 0 means everything went well. You will be returned with some answer. Then 3200, this is a complex value, and within this complex value, the first part, the real part, is the megawatt part, whereas the imaginary part is the megawatt part. But how, I mean, this is not a good way. So if you want to use this in your analysis, what you can do is you have to use the same API in this form. Error, so it will record the error, and then let's use a variable named sysload or system load, or let's say demand is equal to PSSPY dot sys dot, and let's again pass the argument load in this case. So once I press enter, you see no output has come here. Why? Because the output has gone into these two variables. So if I now try to see this variable error, you will see the output is 0. So whatever was here has come here. Similarly, if I see the demand part, I should get the complex demand. So if I want to just use megawatt part in my case, so what I can do is demand underscore megawatt will be equal to, or if you just want to see it, you can write demand is equal demand dot real, and when you press enter, you will get the real part of the demand. If you want to save the real part of the demand in some variable, you can do it like this: demand megawatt is equal to demand dot real. So if you see demand megawatt now, you will have the megawatt part. Similarly, if you want to save the megawatt part, so we can do demand dot image. So once I press enter, so my demand underscore megawatt value should contain the megawatt part of the demand. So this way you can use this. So this is how you use the APIs. It is very important to understand how you use the APIs, otherwise your result will not be good. So moving on, let's try some bus commands. So how about we see the base KV of a particular bus. So PSSPY dot bus dat. So we can use bus dat, and within bus dat we need to give the bus number and then the string or the argument. So I want to check the base KV. So for base KV the argument is base. Again when I press enter, I should be bus. So once I press enter, same thing. So this is the error part and this is the actual. So for this particular bus, the base voltages are 21.6 kV. So again, if you want to use this, you will surely have to save the results somewhere. So what we can do, again, error, some variable for error you need to give, and bus KV. So I want to see the bus KV is equal to PSSPY dot bus dat, again 101 comma, this time let's get the actual KV of the. So once I press enter, now my bus KV part should contain the actual. So my base was 21.6, but my actual KV at the time of this solution are 22.03 kV. If I want to see the per unit voltages, I can see the per unit voltages like PSSPY dot bus dat, and again 101 comma, let's pass P. So once I do this, I can get my per unit voltages. Similarly, if I want to, we can implement this branch data. We saw this branch data. So for the branch data, it will be PSSPY dot BRN is for branch, and then dat for the data. And here we need to pass three arguments: from bus, to bus, and the circuit ID is, since it is alphanumerical in PSSE, so you need to pass this within single quotation or double quotation, comma, and then the argument. So CHARG for checking the line charging of this particular line. So once I press enter, so here my error is 0, everything went well, and the value is 3.5. Similarly, if I want to check some area data, so I can use PSSPY dot AR dat area number. Let's see what is the generation of area number 1. So once I do this and press enter, so once again error, which is 0, everything went well, megawatt part and the megawatt part. So you need to differentiate it. You need to use image and a real part. You can differentiate it. So this way you can retrieve the single element result from your PSSE.